has a number of different beginnings, but for me, it really began in 2005 when my Austrian governor, Arnold Schwarzenegger, and I won't attempt an Austrian accent, made an announcement that the state of California, along with a number of other western states, including Washington and Oregon, and the Canadian province of British Columbia, would commit to making Kyoto-level cuts in greenhouse gas emissions. And when he made this commitment, he said, "I say the debate is over. We know the science, we see the threat, and we know the time for action is now." Well, it's not every day you get to agree with a politician, but I did, especially a Republican. No, I didn't say that. And at that time, around 2003, 2004, 2005, it seemed that the American people agreed. Indeed, a major poll by the Gallup polling organization in 2007 showed that 72% of us were completely or mostly convinced that global warming caused by humans was underway. Indeed, 62% of us believed that life on Earth would continue without major disruptions only if society takes immediate and drastic action to reduce global warming. And even many former contrarians seem to have come around at that time. One of them was the Republican pollster Frank Luntz, who in 2006 said, "It's now 2006. So he was off to a good start. He got the year right. I think most people would conclude that there is global warming taking place and that the behavior of people are affecting the climate. Now, Luntz was important, famous, some might say infamous, because he was the author of a memo to Republican candidates running for office in 2003 in which he addressed the issue of the vulnerability of Republican candidates on environmental issues. Opinion polls consistently showed that the vast majority of American people do believe that the federal government has a role to play in protecting the environment, and Republicans were considered vulnerable on that issue, and particularly on the issue of climate change. So he advised candidates to use the phrase climate change rather than global warming because, he said, climate change is a lot less frightening. Moreover, he went on to say that the way Republicans could win this debate was to reframe it in terms of scientific uncertainty, to emphasize the uncertainties, and to insist that there was no consensus among scientific experts. And so he wrote, and all of the emphasis here is his, "The scientific debate remains open. Voters believe that there is no consensus about global warming within the scientific community. Should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate." Well, was Luntz's position factually correct? The short answer is no. As was said in the introduction, I study scientific consensus and dissent. I had published a paper in 2004 that had looked exactly at this question. And of course, what we knew was that in 2001, the Intergovernmental Panel on Climate Change, the world's leading organization of scientific researchers who study the issue, collect data, and publish it in peer-reviewed journals, had said, human activities are modifying the concentration of atmospheric constituents that absorb or scatter radiant energy. Most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. Now, that was in 2001. So 2 years before the Luntz memo. But in fact, the science had actually coalesced even earlier. In 1995, in the second assessment report of the IPCC, the scientific experts who had reviewed the data had concluded that the balance of evidence suggests a discernible human impact on global climate. Now, in my own research, I had examined the question, or I had posed the question, just because the leadership of a scientific organization says something, that doesn't prove that it's consistent with what the rank and file believe. So if you really want to know what working, ordinary, rank and file scientists believe about a matter, you have to ask what have they published in the peer-reviewed scientific literature. And so that's what I did in 2004. I did an analysis of the peer-reviewed scientific literature using the database of the Institute for Scientific Information. And our analysis of the literature from 1990 to 2000 showed, when we asked the question, how many papers published in peer-reviewed journals disagree with that consensus statement or provide evidence to refute that consensus statement, the answer was none, not one. So that was, I thought, a pretty significant result. And so I thought it was kind of significant. Actually, at first I didn't, but no. It's like a lot of things, you kind of stumble across something. It takes a little time to actually absorb the significance of your own work. So I published it in Science in 2004, and this result surprised many people. In fact, it angered many people. It caused some people to send me death threats, which was really a very strange thing. Because nobody sent a death threat to President George H.W. Bush when he signed the Framework Convention, the United Nations Framework Convention on Climate Change in 1992, which committed the United States, along with 192 other signatories, to preventing dangerous anthropogenic interference in the climate system based on the emergent scientific consensus that we were indeed interfering in the climate system in a dangerous way. Now, when our first President Bush signed the Framework Convention in 1992, he called on world leaders to translate the written document into concrete action to protect the planet. So my co-author and I, Eric Conway, became interested in these two questions. What happened? Why didn't we take those concrete steps that our first President Bush promised us and promised the world? So what I'd like to do tonight is to give you an extremely brief history of the evolution of climate science, just a few key highlights, and then tell the story of the emergence of a political challenge to that science. So this is the story of merchants of doubt. It is the story of selling uncertainty, along the lines of that Luntz memo, of emphasizing doubt, and of insisting that there's no consensus among scientific experts, and motivated, a big part of our story was to explain the motivation, motivated by a doctrinaire belief in free markets, born, nurtured, and hardened in the Cold War. So a good place to begin the story is with the work of John Tyndall, the Irish experimentalist who first established the concept of a greenhouse gas. In a series of experiments in the 1850s, Tyndall showed that certain gases, most notably water vapor and carbon dioxide, have a distinctive property of being highly transparent to visible light, but relatively opaque to infrared. So these gases allow visible light from the sun to penetrate the atmosphere rather readily, but then when infrared radiation is emitted to space from the Earth, it tends to be trapped by the greenhouse gases in the atmosphere. Now, Tyndall recognized that this was a good thing because without greenhouse gases, the Earth would be as cold as the Moon or Mars and quite inhospitable for life. About 50 years later, around the turn of the century, Svante Arrhenius, a Swedish geochemist, recognized that when you burn fossil fuels, it produces a byproduct of carbon dioxide, a greenhouse gas. And therefore, the burning of fossil fuels would be expected to lead to an increase in carbon dioxide in the atmosphere. And that increase could change the radiative balance, could change the heat balance of the planet and make the planet warmer. Arrhenius did the first calculations of what the effect of doubling carbon dioxide in the atmosphere would be and calculated that it would increase the average temperature of the globe as a whole by 1.5 to 4.5 degrees Celsius, or as much as 8 to 9 degrees Fahrenheit. Now, Arrhenius was Swedish, so he thought global warming would be a good thing. The first person to suggest that it might not be such a good thing was this man, Guy Stewart Callender, a British steam engineer, who in 1938 published the first article in a peer-reviewed scientific journal suggesting that carbon dioxide from burning fossil fuels was actually, in fact, already beginning to increase, and that possibly the temperature was beginning to increase as well. Now, that was in 1938. It's quite a while ago. The following year, war broke out in Europe. Callender became involved in war work. Many scientists went off to work on other problems. And the issue wasn't really revisited until the 1950s, or not revisited in a serious way. Now, at that point, people began to discuss one important uncertainty in this whole question, which was the competing effect of water vapor. So I already mentioned that Tyndall had recognized way back 100 years earlier that water vapor is also an important greenhouse gas. And so some people argue that given how much water vapor is in the atmosphere, any small addition of carbon dioxide would not have very much effect. And this is, by the way, an argument that some skeptics and contrarians still try to push today. And it's worth mentioning because this argument is still recycled today, 50 years later. Sometimes people say conservatives don't believe in recycling, but they do recycle refuted arguments. So one refuted argument that they love to recycle is this one, an argument that was refuted in the 1950s by Gilbert Plass, who was a pioneer in upper atmosphere spectroscopy. Plass resolved the absorption bands of water vapor seen here and carbon dioxide seen here, here, and here, and showed that, by and large, they did not, in fact, overlap very substantively, and therefore additional carbon dioxide in the atmosphere would be expected to have a substantive warming effect. Plass's work had a profound impact on two oceanographers in my home institution, the University of California, Hans Suess and Roger Revelle. In 1957, Revell was working on the planning for the International Geophysical Year, and as a part of that planning, he began to think about the possibility of doing systematic observations of atmospheric carbon dioxide. And he pointed out that by burning fossil fuels, humans were taking carbon dioxide stored in rocks over the course of hundreds of millions of years of geological time, and in a very short period of time, just a few decades to a century, we were returning large amounts of that stored carbon dioxide back to the atmosphere. And in doing so, he argued mankind was performing a great geophysical experiment. And so he argued for and obtained the funding to begin the measurements of carbon dioxide as part of the International Geophysical Year. And those measurements became the life work of another professor at the University of California, Charles David Keeling, who in 1958 began the systematic measurement of carbon dioxide in the Earth's atmosphere, which he continued until his death a few years ago, and which his son Ralph continues even today. So Keeling began this work in 1958, and within a few years, by 1965, he was convinced that his own data did indeed show a small but steady increase in carbon dioxide from about 315 parts per million when he began the work in 1958 to about 320 by 1965. By the way, where are we at now? Yeah, just under 400, about 395. So we're up here like heading towards Keeling's face. As a result of these preliminary data, Keeling and Revell concluded that it would be important to begin to communicate with policy officials, government officials, about what this might mean. And so in 1965, as part of the President's Science Advisory Committee, they wrote a report in which they said, by the year 2000, there will be about 25% more CO2 in our atmosphere than at present, and this will modify the heat balance of the atmosphere to such an extent that marked changes in climate could occur. Now, we often complain that politicians don't listen to scientists, but at that time, at least one did. That year, Lyndon Johnson, in a special message to Congress, said, "This generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels." So that was President Lyndon Johnson in 1965. In 1965, we knew that we were altering the chemistry of the atmosphere from burning fossil fuels. But in 1965, President Johnson had a few other things to worry about, and not much serious or sustained issue in the issue was generated in policy circles. That began to change, though, a few years later with a scientific development, the rise of numerical simulation modeling. That is to say, the use of fast digital computers to begin to build computer models, computer simulations of the world's climate system. And for the first time, it began to be possible to model the dynamics of the atmosphere in a quasi-realistic way and to consider long-term trends, or as some people put it, to revisit the calendar question. And these models began to confirm the earlier predictions of Callender and Arrhenius that doubling CO2 would in fact lead to substantive changes in the average temperature of the globe and a whole set of other impacts that then would ensue from that. In the 1970s, then, we see a series of reports being issued from a number of different organizations: the World Meteorological Organization, the National Research Council, the National Oceanographic Agency, the U.S. Department of Energy, the National Academy of Sciences, all of whom begin to discuss what the scientific results are showing and what they mean from a policy standpoint. These various reports led the U.S. National Academy of Sciences to conclude that a plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use. If you go on the internet and you are interested in reading people who attack me, one of the things they like to attack me over is this issue of scientific consensus. There's a new project that just started in Australia of a group of climate contrarians who call themselves the Galileo Project. I mean, this is kind of, the narcissism of this is unbelievable. And one of the things they like to say is that science isn't about consensus. It's about heroic individuals who reject the conventional wisdom. Well, actually, science is about consensus, and this is the U.S. National Academy of Sciences saying so. So this isn't my word, this is their words. This is how the scientists themselves thought about their own work, a kind of emerging consensus of opinion based on scientific research and data. So in 1979, there was a consensus that global warming would happen, that it was expected to occur. So this, in effect, is a consensus about an expectation.